Okay. Uh, Another a smooth sphere P excuse me of mass 3m moving with speed 4u. Okay, and so we have a before and after picture. Okay, before and after. Now 3m, 2m. Lads, by the way, easiest question on the test consistently over the years is collisions. You should be pretty close to getting 40 or 50 near, no matter what year you're doing. You should be on the mid 40s. They're so easy. Okay, and what 2m and 2m is it's going with speed 4u this way, and then the 2m is going in the opposite direction with speed 3u. Okay, that makes a relative velocity of 7u when they hit into each other, right? Okay, and then we go m1 u1 plus m2 u2 PCM, principle of conservation of momentum, m1 v1 plus m2 v2. Okay, now what we have is 3m times u. What's u1 for u? We got 2m times minus 3u because it's gone in the opposite direction, and that equals mv1 plus mv2. Just keep a close eye. All the m's cancel, and I think I'm left with 12 minus 6. 12 minus, oh wait, made a mistake there. It's a 3m, that's a 2m. Let's be careful with the m's. So what do we get? 12mu minus 6mu, which is 6mu, equals 3mv1 plus 2mv2. The m's will cancel and we get 3v1 plus 2v2 equals 6. Everybody get that? Okay, let's go with yes. Oh, wait a second. Left out a piece of information there, didn't I? Brought to rest. If it's brought to rest, what does that mean about phi1? Phi1 is actually 0. Make sure you read everything. So 2v2 equals 6. Phi2 equals 3. What? You what? Oh, 3u. Yes. 3u. Cool. Now, Newton's experimental law. So that's 0 afterwards is 3m, and that's 2m, and it's going now at speed 3u. Okay, phi1 minus phi2. The way I memorize this is the difference in your velocities after the collision is a fraction of what it was before the collision occurred. So that's it there. Now what's phi1 minus phi2? Is 0 minus 3u, and then on the other side it's going to be e. Do we know the e value? We don't know the e value, but we know that u1 minus u2 is 4u minus bracket minus 3u. So that makes it minus 3u equals minus 7ue. Take out the u's, divide across by minus 7. U equals 3 over 7. That will get you 15 out of 25 marks just for that. Okay. Next thing after that is it wants me to do the determine the fraction of total kinetic energy that was lost during impact. Fraction that was lost. Fraction lost. Okay. Ke lost over Ke before. There's no need to multiply by 100. It says fraction, doesn't say percentage. Ke lost is Ke before minus Ke after, all over Ke before. So what is the kinetic energy before? It's there's two bodies moving, a half mv squared plus another half mv squared, but they're different masses and they're different velocities. So the first one's a half 3m squared, yeah? Oh, sorry, 3m times its velocity. Its velocity was 4u squared. And the second one is a half 2m, and its velocity was minus 3u squared. Both of them added together get you 33 mu squared. Now, your velocity after the collision, only one of them is moving. It's a half the 2m particle is moving after the collision, and that's 3u squared. And then we got what was it? 9mu squared. So, how much did we lose? We lost 24, didn't we? So it's 24 mu squared lost divided by our original 33, and we get 8 out of 11. How many people got that one completely right? Yeah. Collisions. Invest your time in collisions, guys, if you haven't already. They're just marks galore there. Now, is that one done? Any questions? We're good. Next one. Two small smooth spheres A and B of equal radii but of masses 20 kilograms and 10 kilograms respectively lie in a smooth horizontal table. B is at rest. A is moving at 4 meters per second, strikes B obliquely, and then after the collision, the direction of A at the moment of impact making an angle of 80 degrees with the line of centers. The coefficient, the E value is a half. Find the speed of A and the speed of B directly after impact. See the word speed. What's significant about that? If it has two components, you're going to have to do Pythagoras' theorem. If it just has one component, you're grand. But just remember the difference between speed and velocities. People lose marks every year over that. Now, identical, two smooth spheres. Oh, 20. 10. Going this direction at 4. 60 degrees. 4 cos 60. 2 and 2 root 3. Okay, and the second one is at rest. What you guaranteed after a collision occurs? What you guaranteed? Huh? Yeah, you're guaranteed to change direction, but only one of the components changes. Which component is it? The I component changes, however the J component remains the same. This one had no initial speed, so it's just gone across with phi2. There's nothing too bad about that. Okay, and I haven't done any formula just yet, so I need to get cracking on that. Okay, PCM, principal conservation of momentum. M1 by U1. 20 times. Now people wrote down 4. It's PCM along the I direction. Conservation of momentum takes place along the I direction. So what we have here? Well, it takes place in both directions, technically in any direction, technically speaking, but we zone in on the I direction. Okay? So 20 times what? 2. The biggest mistake was 20 times 4. Okay? And then 10 times 0 equals 20 times V1 plus 10 times V2. And then we should get 2V1 plus V2 when you divide both sides by 10 equals 4. Now you have NEL, Newton's experimental law. You got V1 minus V2 equals minus E into U1 minus U2. Everybody cool with that? Now, we're going to have next is V1 minus V2. So that stays the same. The E value was a half, wasn't it? Half. And our U1 minus our U2? 2 minus what? 0. phi1 minus phi2 equals minus 1. Okay, you're going to solve them in the usual manner. Do we need both of them, or do we just need one of them? No, we need both of them. So look, I won't bother with the actual simultaneous equation because we all know you can do them. Okay, phi1 ends up to be equal to 1, phi2 ends up to be equal to 2. Is that right? Now that happens, what can you tell me about this, the angle after impact? So, sorry guys. Speed of A is 1 meters per second. Speed of B is 2 meters per second. The angle between their directions after impact. This question was, people found it quite tough. The second particle is going directly to the right, so there's no worries there. We just need to worry about the angle that A is making. It's going 2 root 3 into the air, and how far is it going across every time? We got it there a second ago. 1. It's going 1 across, and it's still remaining at 2 root 3 upwards. An angle bigger than 45 or smaller than 45? Anybody tell me? Bigger than 45 or smaller than 45? Angle angle X here. Bigger than 45, okay? So, tan inverse 2 root 3 over 1. You find out it's 73.9 degrees. You're currently on 20 marks, okay? You're on 45 out of 50 for the question overall. And then finally, the loss in kinetic energy due to the impact. Loss in kinetic energy. So, just simply Ke before minus Ke after. So a half 20 times 4 squared. Your mass is 20, your overall velocity or your magnitude is 4. Take away. Now here's the hard part. See this 2 root 3 and 1 business here? That's particle A. How fast is it actually going? We need its magnitude, don't we? So we need to do Pythagoras' theorem. Upon doing Pythagoras' theorem, you'll find out that this side is root 13. So it's actually going root 13. So your kinetic energy afterwards is a half. That's a 20 kilogram object, and it's going at root 13 squared. You forgot that B is also moving. B is a 10 kilogram object, and it's moving 2 meters per second directly to the right. So everything, kinetic energy before minus everything from the kinetic energy afterwards, and that will give you 10 joules. Or if you want the breakdown, it's 160 for that, it's 130 for that, and it's 20 for that. Gives you 10 joules. Everybody happy enough with that? Okay.